Hello everyone, I am Shikha Srivastava, Director and Board Member CDOT India. I'm really pleased to be here with all of you in the 9th Global 5G Event 2022. I would of course have liked to be there in person, but today I will be presenting virtually. Today I will be speaking on prospects from 5G and 6G wireless communications in India. This is the brief outline of this talk. Let me tell you something about CDOT, which is Center for Development of Telematics. It was established in 1984, and it is an autonomous telecom technology R&D center of the Government of India, and it is one of the pioneers of indigenous telecom technology in India, and it has a number of products in the area of optical, mobile, switching, Wi-Fi, M2M, telecom security, telecom software products, and now it is working in quantum key distribution, post-quantum cryptography, computer vision, and natural language processing. These are some of the CDOT 4G and 5G products. We have products in the 5G, core and RAN, and as well as in the data plane acceleration. We have also got M2M solutions. And in the 4G arena, we have the 4G LTE RAN, 4G core network, IMS, and high-speed routers, as well as M2M interface. We had pioneered this unique solution of providing active sharing of radio resources by multiple operators in the 2G, 3G mobile communication space. Now we will go on to the 5G and 5G. 5G plays on low latency, high bandwidth, and machine type communication. Network slicing and edge computing are its strengths. It benefits multiple industry sectors by providing improved real-time machine-to-machine communication. In the Indian context, it powers useful applications like remote healthcare, remote classrooms, and precision agriculture. Consumers get a host of advantages too, such as faster and uninterrupted browsing, better connectivity at mega events, smooth experience of augmented and virtual reality, ultra-high resolution TV, and 4K video telephony. I would like to mention that 5GI is the Indian contribution to 5G standards and proposes low mobility large cell. It brings ultra-fast connectivity to larger areas for pedestrians and low-speed vehicles, and it allows greater distances between base stations. Since it involves a software-only change, it is also cost-effective. As part of the Indian government's focus on digitalization, the 5G rollout in India starts in the month of October this year in 13 selected cities and will proliferate to other parts of the country in the next few years. Here are some interesting stats from the Indian telecom scenario, which has the highest bandwidth usage and the lowest revenue. India has 1.1 billion subscribers and bandwidth usage of 15 GB per subscriber per month. 5G is evolving and faces challenges like intercell interference, impacts the UEs at cell edges. 5G requires more antennas for uniform network coverage as compared to 4G, and therefore the initial costs for 5G rollout are high. The number of devices supported by 5G is 50K per cell, which needs to be improved upon. Security researchers have uncovered several vulnerabilities in the network protocols that permitted man-in-the-middle attacks and DOS attacks. The battery life of the devices is lower and heated devices have been reported. Upload speeds are much lesser as compared to the download speeds. Limited coverage is there in higher bands due to attenuation of signals, and interference with flight operations have been experienced in some countries. 6G wireless communications. 6G is the successor to the fifth generation of wireless communication and slated to overcome some of the 5G limitations. Two key drivers for building 6G are increased speed and lower latency. 6G system will be an intelligent system which is both human and machine centric. Advanced edge computing and powerful AI systems will provide advanced levels of automation. The 6G core network is more intelligent with higher computational power and higher capacity. The access network is heterogeneous with base stations and access points, satellites, UAVs, and multiple devices. Fog computing, mobile edge computing, vertical handoffs are integral components of the 6G network. 6G delivers user data rates of 1 Gbps per user. The enhanced spectral efficiency enables a large number of users to access advanced multimedia services instantly and simultaneously. The latency drops to 1 millisecond in 6G as compared to 5 milliseconds in 5G, benefiting mission-critical applications. 6G improves network reliability by more than 100 times and error rates by 10 times. 6G also improves the battery life of devices and energy efficiency of networks by 2 times. And with 6G, we can expect to connect 10 times more devices per square kilometer. The few common and important issues related to the service quality of 5G and 6G communication systems are high capacity, high security, massive and reliable connectivity, low latency, low energy consumption, and high quality of experience. Of course, 6G communication will provide several-fold improved performances compared to 5G communication systems with respect to these. So, as we can see, the improvements in 6G are wave for mobile access and exploration of higher frequency and terahertz bands, non-RF communication based on visible light and optical systems. The devices, if we see, are also enhanced, connected robotic and autonomous systems, brain-computer interface, enhanced XR, smart implants. The architecture of 6G is innovative. It provides for cell-free architecture, intelligent reflecting surfaces, wave tiny cells, temporary hotspots served by drone carrier base stations or tethered balloons, tiny terahertz cells. The services would be human-centric services, multipurpose services, mobile broadband, reliable low latency communication, and massive ultra reliable low latency communication. There would be many new 6G applications about which we cannot even imagine now. Then there would be those who would be 5G applications in a improvised better user experience avatar. Now some of the applications would be high performance precision agriculture, real-time remote healthcare, holographic communication wherein high fidelity holographic images would crop up at the touch of a button and provide a lifelike yet virtual interaction. Space flights, space tourism, space research are some of the applications. Robots diagnosing monitoring, operating, maintaining factories, homes, and so on. Many new research areas are emerging in 6G, especially if we see the air interface. There are a lot of innovations here. Multiple access schemes like non-orthogonal multiple access, rate splitting multiple access, new modulation techniques like orthogonal time frequency, space modulation, spin angular momentum, and orbital angular momentum, as well as exciting AI-based schemes that trade block size, latency, retransmission, and energy consumption. The emergence of virtual massive MIMO and ultramassive MIMO with tens of thousands of antenna elements. Intelligent reflecting surfaces can be used for beamforming. They consist of a large number of low power and low cost passive elements to reflect the incident signals with configurable phase shifts without any requirements of additional power, encoding, decoding, modulation, or demodulation. The main advantage of IRS is that it can enhance the signal to interference plus noise ratio with no change in the infrastructure or the hardware of the communication network. Can you even imagine that 6G would incorporate mobile edge computing functionalities on aerial platforms and low orbit satellites for all-around connectivity? AI will ensure safe failure detection, early failure awareness, bringing a paradigm shift towards less human-controlled wireless systems. Incorporating AI in wireless algorithms at the RAN for channel estimation, channel state information feedback and decoding, etc. Transmitters would have the ability to self-organize and configure according to channel condition and workload. Quantum can be used for cryptographic key exchanges, and network optimization problems may be solved as quantum computing enables NP-hard optimization problems to be solved in linear time. Tactile internet would provide the internet of senses and enable transmission of senses. That's all from my side. Thank you for your patient listening.